Our next question is, a 1.2 meter tall girl spots a balloon moving with the wind in a horizontal line at a height of 88.2 meter from the ground. The angle of elevation of the balloon from the eyes of the girl at any instant is 60 degrees. After some time, the angle of elevation reduces to 30 degrees. Find the distances traveled by the balloon during the interval. So a girl is observing a balloon which is flying in the sky. At first it is at this position. So at that moment when she observed the balloon at an elevated angle 60 degrees, and after that after some time the balloon moved from here to there, and then this girl observed that one at an elevated angle 30 degrees. The balloon is at every moment, like when it is here or when it is there, at every moment the height of the balloon considered from the ground level is 88.2 meters, and even the height of the girl is given 1.2 meters. So the observable height means from the line of sight of the girl, that means this line, from the line of sight of the girl, the height should be calculated for the sake of trigonometric ratios. So that height is 88.2 meters minus this 1.2 meters. That much height we need to consider. So whenever you are drawing triangles which leads to some trigonometric ratios, at that moment the height considered for the triangle will be that 88.2 meter minus 1.2 meter, because so the line of sight is taken as base for the triangles that we are drawing. So in this I want to name the triangles like A, B, C, D and E. So here I can see two triangles with some elevated angle 60 degrees and 30 degrees. So first notice the triangles. So triangle ABC is a triangle which contains an elevated angle of 60 degrees, and the triangle ADE is another triangle which contains the elevated angle 30 degrees. These two triangles we can observe, and even ED is calculated using the given things, like the ED is equal to the exact height of the balloon from the base, which is 88.2 meters minus, so we need to consider the height of the balloon from the line of sight of the girl. So we need to subtract the girl height which is calculating from the ground, so that is 1.2 meters. So on a whole you will have 87 meters. For simple calculations I want to write this one as 3 into 29. 3 29s are 87. Let it be like that. So now I want to get the trigonometric ratios. So first of all I am considering tan 60. Tan 60 is equal to opposite side, that is BC by AC. BC by adjacent side AC. And then tan 30 is equal to opposite side ED by AD. Why should we need these ratios? Because we need to find out the value CD or B, this length, because we need to find the distance traveled by the balloon during the interval. So from here to there or here to there, both are same only. So that distance we need to find out. To find the CD we need AD and AC, and those AD and AC are the bases of these two triangles, so that we are aiming to find that sides. So from this AC is equal to BC. BC is this much height, which is same as this one, which is 87 meters. So 87 divided by tan 60 is root 3. Okay, one expression came. And now AD is equal to ED also 87 divided by tan 30 is 1 by root 3. So this will leads to 87 root 3 meters. So we got AC and AD. Now we need to find out CD, where CD is equal to AD minus AC, whereas AD is 87 root 3, AC is 87 by root 3. Take 87 as common here, so you will have root 3 minus 1 by root 3 meters. So if we simplify that one, 87 can be written as 3 into 29, and this one by taking LCM you will have root 3 in the denominator, and root 3 into root 3 3 minus 1, which is 2. So this root 3 ones and 3 I want to cancel with root 3 times. So it will be 29 into 2, that is 58 root 3 meters is the distance traveled by the balloon from this point to that point. Students, you can substitute root 3 value and get the final answer here. The main turning point is relating the bases with the given trigonometric ratios for the elevated angles and then finding the distances. For that we subtracted the relative distances.